Okay, let's look at an Anova, which is a way to compare multiple means instead of just limiting ourselves to two means like we do in a two-sample t-test. An Anova allows us to compare multiple means and then determine if there actually is a difference. So this way we're looking at the efficacy of a new antidepressant drug. And each patient was assigned to one of four groups. They did a placebo group, and then they did 3 different levels of dosages. After a certain period of time, each person took a depression inventory and to indicate if the drug actually helps with their score or caused lower scores in the group. So we want to compare our 4 groups. So you can see the sample sizes are different, which is more than okay. And our ANOVA allows us to compare the means across all 4 of them. So as we scroll down here, our state step is just there is a significant difference in the mean results based on drug dosage, meaning somewhere in there, there's a difference. That doesn't mean that they're all different, but it means that there is a difference somewhere in our results. So our null hypothesis is that the mean of each group is equal. So the mean of the placebo equals the mean of the low dose and so on. We are testing against our null hypothesis, and our null just says across the board everything is the same. We want to prove that somewhere at least one of the means is different. We can't say that all the means are different because there is a possibility that 2 of them have the exact same mean. We don't know that, but we want to prove somewhere that there might be a difference. So our alternative is that not all means are equal. So we go over to StatCrunch here, and if you want, feel free to type in your data. Once you do that, feel free to pause it. Once you do that, I'm going to walk you through the ANOVA here. So to do the ANOVA, you're going to go to Stat, ANOVA, and we are doing a one-way ANOVA. To get all of them in there, you'll click on the first one, hold down the Shift key, and then click on the last one, and it should select all 4 of them. And then all you need to do is hit Compute. Once you compute, you're going to get an analysis of variance table here. Our main concern again is our p-value, which goes with all of our testing. A low p-value, less than 0.05, indicates that we reject our null and accept the alternative that not all means of the groups are equal, meaning that somewhere in there we've got a difference in means. Our f-stat is fairly high compared to the scores. The f-stat, there is no exact number we're looking at. We're not going to say it's greater than a certain number, but compared to what our averages are, our f-stat is pretty high. So a high f-stat, a p-value less than 0.05, that's an indicator that we reject our null and accept our alternative, that there is some difference within our results. Now if you look up at the top table there where it says the column means, you can look at the means of each group, and it's obvious that the placebo group has the highest mean. That indicates that maybe we should test that the placebo group is greater than the high dose group, and you can continue a test there. Our lowest group looks to be the moderate dose, and we could do some further testing with 2-sample t-tests to see if that's really the case. The other thing you need to look at this table is the standard deviation. And one of our conditions for an ANOVA is that the standard deviation should all be fairly similar. Obviously, the high dose has a larger standard deviation than the other 3. The other 3 are very close. And the rule of thumb is that the highest one is no more than 2 times the size of any of the smaller one. Well, our high dose is less than 14 because 7 times 2 is 14, so we know that we are okay.